In this video, I'm going to take you through problem numbers 1 through 5 on the sample chapter 5 test that involve inverse trig functions. Before we go over inverse trig functions, I want to remind you how to take just regular trig functions of an angle measure. If I wanted to find the cosine of an angle, I would go to that angle on the unit circle, and the answer would be the x-coordinate. Similarly, to find the sine of an angle, I would go to that angle and the answer would be the y-coordinate. To find the tangent of an angle measure, you would go to that angle and take the y-coordinate and divide it by the x-coordinate. To find the secant of an angle, you would go to that angle and then take the reciprocal of the x-coordinate. To find the cosecant of an angle, you would go to the angle and take the reciprocal of the y-coordinate, and to find cotangent of an angle, you would go to that angle and take the x-coordinate and divide it by the y-coordinate. An inverse trig function is doing the opposite. So we will be getting back to the angle measure. So first off, it's good for you to know that the answer to all inverse trig functions are angle measures. The answer to an inverse trig function is an angle, but it is a very specific angle. For example, the answer to inverse cosine can be an angle on or between 0 and 180 degrees. The answer to secant inverse can be an angle measure between or on 0 to 180 degrees, just not 90 degrees. And the answer to inverse cotangent can be an angle measure not including 0 and 180, but any angle measure between 0 and 180 degrees. You can look at the chart I've made you here to see what specific angle measures these inverse trig functions can be. Looking at the chart, I want you to notice that all of the inverse trig functions that I wrote on the left have answers in quadrants 1 and 2, and all of the inverse trig functions that I've written on the right are located in quadrants 4 or 1. In this particular instance, you could just look at my chart to know where the answers to inverse trig functions could be. But ultimately, it would be a good idea if you knew where they were without looking at a chart. At the very end of this video, I'll give you a silly story that might help you remember where to look for the answers to all 6 inverse trig functions. Ultimately, to find the answer to an inverse trig function, you can go to your unit circle and ask yourself the question that goes with the inverse trig function. This will be a very good reference page for you. But we're going to just jump in and start using these questions to find the answer to inverse trig functions in our first problem. In problem number 1, we want to find the exact value of sine inverse of root 2 over 2. If we want to find the exact value, this means you're not going to grab your calculator to find the answer. You want to use the unit circle. You don't want to settle for a rounded value of a decimal. Okay, remembering that the answer to all inverse trig functions is an angle measure, we might write equals theta. To find the answer to inverse sine of root 2 over 2, we want to ask ourselves what angle from negative 90 degrees to 90 degrees is the y-coordinate, in this case, root 2 over 2. So we're going to look at a unit circle and we're going to look for a y-coordinate that is root 2 over 2. The only place we can look is in quadrants 1 or 4. We notice at 45 degrees the y-coordinate is root 2 over 2. So the answer to inverse sine of root 2 over 2 is 45 degrees, or if we want the radian angle measure, it would be pi over 4. The next question is find the exact value of inverse cosine of negative 1. Remember, the answer to all inverse trig functions is an angle measure. Since it's an angle measure, I might want to say equals theta. Okay, then I ask myself the question, what angle on 0 to 180 degrees is the x-coordinate, in this case, negative 1? So I want to grab a unit circle and start looking for where on the unit circle there's an angle measure with x-coordinate negative 1. I can only look in quadrants 1 and 2, and the angle measure where the x-coordinate is negative 1 is at 180 degrees. So the answer to inverse cosine of negative 1 is 180 degrees, or in radians, the angle is pi. Question number 3 said, find the exact value of inverse tangent of root 3 over 3. Remember, all answers to inverse trig functions are angle measures. So tan inverse of root 3 over 3 is going to equal some angle measure. I called it theta. I ask myself what angle from negative 90 to 90 degrees is the y-coordinate divided by the x-coordinate, in this case, square root of 3 over 3. When I look at my unit circle, I can only look from negative 90 degrees to 90 degrees, so quadrants 1 or 4. I notice that at 30 degrees, the y-coordinate divided by the x-coordinate is the square root of 3 over 3. We'll do a little bit of scratch work to show you that this is true. If I take the y-coordinate 1/2 divided by the x-coordinate root 3 over 2, then I'm going to take the reciprocal of the second fraction and change that to multiplication. I can cancel the 2's, multiplying straight across. I'm going to get 1 over the square root of 3, rationalizing the denominator by multiplying by root 3 over root 3. I end up getting the square root of 3 over 3. So the y-coordinate divided by the x-coordinate at 30 degrees is root 3 over 3. The answer to our inverse tangent is 30 degrees, or pi over 6. Okay, problem number 4. Find the exact value of sine inverse of sine of 9 pi over 8. We're going to start by doing what's inside parentheses first. So we want to find the sine of 9 pi over 8. We want to go to the angle measure 9 pi over 8 on the unit circle, and the answer to sine is the y-coordinate. If you feel more comfortable working in degrees rather than radians, you could multiply the angle 9 pi over 8 by the conversion factor 180 over 2 pi. We could take the sine of 22.5 degrees instead. So I'm going to go to the unit circle, and essentially I'm looking for the y-coordinate at 22.5 degrees. At 22.5 degrees, we don't have a coordinate that's on our standard unit circle. So I'm going to go ahead and estimate what I think the y-coordinate there would be. This is a unit circle. So since it's a unit circle, from the x-axis all the way up to this first yellow line that I'm drawing is a distance of 1. And then at 45 degrees, the y-coordinate is root 2 over 2, which is about 0.7. And then at 30 degrees, the y-coordinate is 0.5. The y-coordinate at 22.5 degrees has got to be smaller than 0.5. I'm just going to estimate that to be about 0.4. So the estimate for the sine of 22.5 degrees is about 0.4. Okay, so then we're trying to find the inverse sine of about 0.4. Remember, the answer to all inverse trig functions are angle measures. So we ask ourselves the question, what angle measure from negative 90 to 90 degrees does the y-coordinate equal about 0.4? Well, that's just going to be the angle measure we just had. So the answer is 22.5 degrees. Remember, we can only look for the answers to inverse sine from negative 90 to 90. And so if we're going to have a y-coordinate of 0.4, that's going to happen at 22.5 degrees. We could call it instead 9 pi over 8. Either one of these answers would be just fine. On to number 5, finding the exact value of sine inverse of tan of pi over 4. We're going to start by finding the answer to what's inside of parentheses first. To find the tangent of pi over 4, I'm going to go to the unit circle and take the y-coordinate divided by the x-coordinate at pi over 4. So I'm going to have the square root of 2 over 2 divided by the square root of 2 over 2, which happens to equal just 1. So I'm going to replace the tangent of pi over 4 with the answer 1. Now I need to find sine inverse of 1. To find the sine inverse of 1, I want to ask myself, what angle measure from negative 90 to 90 degrees is the y-coordinate equal to 1? So looking only from negative 90 to 90 degrees, I see at 90 degrees the y-coordinate is 1. So the answer to sine inverse of 1 is equal to 90 degrees. If you want the angle in radian mode instead, then the answer is pi over 2. I did tell you at the end of the video I would share with you a way to memorize where to look for these inverse trig functions. Unfortunately, my story is too long to fit in this video. If you are interested, I will make another video so that you can hear my stupid story.